Thank you, Roger. It was good to connect here, JD. My name is Ramni Narayan from Michigan State, and Roger Cargill is from Finite Phoenix. And today we offer three innovations, sort of across the board. One is the innovation on plastics. Of course, you've been inundated with the word plastics and microplastics. The second concept there is the emerging new compostable plastics, and how do I provide an infrastructure that can be used to remove that from the environment? And the third one is this enormous food waste issue which we are. And we are fortunate that we have the Henry Ford Health System to provide us the platform to execute this technology. So let's dive deep in. The plastics problem, of course, everybody is familiar with, and I was pleased to be on this National Academies of Science and Engineering report on global ocean plastic waste, which lays bare the issue or problem with this. Now, 90% of the single-use disposable packaging plastics are what I call carbon-carbon backbone polymers. And sorry if I went a little technical, but essentially these are carbon-carbon linkages, which is the most strongest bond we have ever made. And therefore, at the end of life, it's difficult to break down, to recycle or biodegrade, and that's a big problem, right? And so you're left with this persistent, accumulative, non-biodegradable plastics. And so there has been a major effort, the last 20 years I've been involved with, was redesign that carbon-carbon backbone with another backbone that is more labile, that I can depolymerize or break it down, and which I can compost or biodegrade. And that has resulted in things like PLA, the world's foremost 100% bio-based biodegradable polymer, which was developed in my lab, and the PhD student's thesis still is the Bible, the reading material for both companies involved in PLA, right? Now, that's one side of the problem and a potential solution. The next problem, which is tied to this, is this biodegradable organic waste. What do I mean by that? Well, 50%, just imagine, 50% of MSW, municipal solid waste, is food, paper, and organic waste. Today, that is contaminated with all these packaging plastics. You just have to look at it, the thin films, the wraps, and all those things. And what do we do with it? We send it to a landfill. Given the environment, the anaerobic environment, this results in a 25x GWP, global warming potential impact. So clearly, something has to change in this. And one of the solutions, obviously, is diverting the food waste to industrial composting facilities and manage it so that no methane generations happen. But there's plastics, and they form microplastic. So clearly, plastics associated with this MSW, this food waste, has to be also compostable. And therefore, the solution we are offering then is that if you have certified, verifiable compostable plastics, and I've been privileged to develop the standards which are the basis for defining compostability and biodegradability, that in conjunction with food waste diverted to a managed end of life like composting provides a circular closed loop system to manage plastics, but also manage the waste stream, right? So that's kind of where we are talking about. And just for numbers' sake, remember that 1 million, 1-to-1 equivalents. If you divert or recover 1.84 million metric tons of biodegradable organic waste, you would get savings of 1.74 million metric tons CO2 equivalent GHG saving. Dramatic impacts by just switching how we do business. So what is the innovation we are talking about? So we are proposing to use composting, and composting everybody thinks has been around forever. So what is innovative about composting? And what we are saying is we are talking about a two-stage model where we will look not only at the food and organic waste, but also the compostable plastics, and generated at hospital patient kitchens. You see the conflage of plastics and food, and then compost it in the format we are talking about. So we plan to use a flow composter that would treat this waste. And the Henry Ford system is going to provide us the platform to do that. And we are going to do the research. So the deliverable is actually on a non-profit, scalable, continuous flow composter. It will provide a stable amendment product. It is on site to deal with both plastics and food waste, and therefore solve a problem which exists today. That was 5 minutes.
Thank you.
You guys steamed it wrong.
Well, good job.